Good morning, friends. So here we can see the pictorial representation of foundation. Okay. So here the main major classification in the diagrammatic view. So we have classified into two categories, that is shallow foundation and deep foundation. Shallow foundation and a deep foundation. So here D, depth of the footing, is less or equal to its width W. Here D is greater than its width. Okay. Deep foundation. Now in shallow foundation we have spread, combined, strap, mat. Okay. So in spread itself, okay, we have seen no so many categories. Spread itself, single. Okay, what are the next? Single, stepped, sloped, wall with step, wall without step, grillage. Okay, this is we need to discuss. Okay, so in the previous class we have studied these things. Okay, now in the combined also, depending upon its geometry, we have rectangle and we have trapezoidal, like this. Okay, like this. This is a plan of the foundation. It is not a cross section or elevation. When you see from the top, the plan of the foundation appears like this. These are hatched portion of columns. These are hatched portion of columns. Okay, like this. Okay. Just I want to tell here, when rectangle combined footing is provided means when this column carries equal load, then we provide rectangular combined footing for two columns. When trapezoidal is provided, when this column carries larger load and this column carries a smaller load, so to counteract that one, we are providing with what? Trapezoidal. Why? For larger load, you require larger area of foundation. For smaller load, you require smaller area of foundation. But these two columns have only one footing. That is why we call it as a combined footing, but it is in the rectangle trapezoidal. And here we are providing one combined for column as well as wall. We will see it in the diagram, then it is clear. Okay, then it will be clear. Now shallow is classification here. For deep foundation we have pile, pier, well. Okay, in pile also we have end bearing, friction, combined end bearing and friction, compaction. Here in pier, masonry and drill casing. We will see the diagram and then discuss, no problem. Okay, just I wanted to show how the classification is. This will give a better idea compared to the continuous thing. Okay, now we have seen this spread. Okay, in that spread also we have seen these four categories, four or five categories. This is pending. Okay, now we will see in the diagrammatic portion how it is there. Shallow foundation, simple, where depth is less than its width, and it is going to spread that one. Okay, it is going to spread to a larger area. This diagram already shown. Now classification just now we have seen. Okay, now it is also what is this spread footing. Here a typical spread footing for column is shown. So the meaning of this word spread, what it is doing, whatever the load coming from the column, it is transferring to this larger area. It is transferring it to the larger area. That means spreading the load over a larger area. So that is we call it as spread footing. Now in spread we are going to see this one. Let us see this one. Single footing, like this diagram you will be easily understanding. No, in some of the construction of any building you will be already seen this one. You have already seen this one. So here column and its reinforcement is shown. It is called as reinforcement. Okay, so vertical bar, horizontal bars is there. Similarly for foundation, this is also called as a footing slab. We have slab for roof also. So similar way for footing also we are providing a slab type of a structure. It also contains reinforcement in horizontal and in as well as in vertical, sorry, what is this, x and y direction. So it is also provided. Now here this area we call it as small b, small w. Width and breadth. Here for footing we can call it as B and W, like this. Any way it is possible, just for understanding I am telling. Dimensions are for footing are capital B and W, here small b and W. Now loaded area, it is spreaded area, means what? This is the loading portion, this is the loading portion, this is the spreading portion, this is what? Spreading portion. Here they have used D, no problem, just to understand. Smaller area, larger load is dissipated or spreaded to a bigger area, and it is resting on what? Deep ground or soil. Okay, on soil. Is that okay? How this single word means what? For one footing, one column, one separate footing is provided, okay. Okay, now we will see the next diagram. Okay, now, this is a typical diagram for stepped footing. Previous, there were no steps. Here, steps are provided. Can you see this diagram here? Can you see this one? Here, full base is there, and one step is provided, another step, third step, and this is the top column is coming. Okay, so a concentrated load or larger load, the load is transferred like this. Okay, using steps. Okay, so it is here for heavy loaded structure, like this it is spreaded. So you can here also see the bottommost is called as raft, step 1, step 2. After excavation and before footing, there is one small layer. What is this? PCC stands for plain cement concrete. Plain cement concrete means no steel or no reinforcement. Okay, if it is steel is provided, then instead of PCC we call it as RCC. Okay, reinforced cement concrete, plain cement concrete. Okay, so like this it is provided. This is called as raft, step 1, step 2, like this. These are called, just to make you people more understanding. See why I have taken these pictures means it will give a proper understanding how actually inside it is done. Okay, I hope it is clear now. Stepped footing. Okay, now this is a bigger picture. Okay, this is a bigger picture of the stepped footing only, no problem. Okay, here bottommost raft, one step, second step, third step, like this. Later it will give column. So inside also steel is provided, reinforcement. So it's called as a raft portion. Bottommost, step 1, step 2, column. Step 1, step 2, column, like that. Okay, stepped footing. What is this next one? What we are going to see? Sloped footing. Okay, in the previous class we have seen in diagram also. Here again you can see. Here what they have done, bottommost made a proper rectangle type of a thing. Later that portion is joined here. It is called as sloped isolated. Sloped and isolated. Isolated means what? Single footing for single column. Okay, like that. Sloped means what? From the edge of column base to this raft top, the concrete is poured in a slopy direction. Steps are not there, but instead of that, one continuous concrete layer is made. So this is called as sloped footing. Or else you can also say PCC is there. From the PCC top, you are providing a sloped footing itself. That is also possible, no problem. Okay, whatever there is, if there is a slope kind of a thing, then we call it as sloped footing. Okay, I hope it is clear now. Now we can see this is a typical diagram for wall footing without step. You understand, wall footing without step. See, continuous wall is running, and one footing is provided. In the top view, it appears like this. Bottom bigger rectangle is this portion, and top hatched portion is this wall. Okay, is that okay? Wall footing with without step. Okay, now go to this diagram. Very clear now. In this diagram, wall footing, it should be with step, By typing mistake it is like this, out is not here. Okay, it is with step. So you can see from the wall base to the footing top, the footing is made in a stepped way, it is made constructed in the steps. Okay, so in top view it appears like this. These are all comes under spread footing in shallow foundations. Okay, now this is also one typical diagram. In the cross section you can see this is a pad footing is nothing but spread footing only, isolated spread footing, no steps and no slopes. Here stepped, here it is a step appears like this, and here the slope appears like this. Okay, is that okay? Okay, again some more diagrams are there. Some more diagrams are there for isolated spread footing, isolated spread plus stepped footing, here isolated spread plus slope footing. Okay, these are the isometric view, these are the plans. Okay, now we will come to combined footing. What is there in the combined footing? When with one single footing supports two or more columns, or one column one wall. Okay, so when for the two or more things we provide one common, that is called as combined. Depending upon the plan, when you see the plan, if it appears rectangular combined footing, if it is a shape is some the trapezoidal, means it is a trapezoidal combined footing. Now you can see in this diagram, it is for rectangular footing. Here only you can understand this kind of a footing are adopted when columns carry equal load. This is also W, this is also W, or W1, W2, W2 and W2 are equal. Okay, it is designed in such a way that CG, center of gravity of loads, coincides with the centroid of the footing area. So when you might have studied in the engineering mechanics from your first or second semester, CG and all. So you have seen the combined, what is that? One small square is there, one like this arc is there. So you are calculating X and Y direction, CG calculation, no? From here to here, from here to here. So in that way you understand this point also. When you take this and this, its CG lies in this vertical axis. Okay, is that okay? When you take this column and this column, when you calculate its center of gravity line, it will fall in this line, in this plane. And when you take this common, what is this, footing, and its line also following the same, its line is also coming in the same line of CG of columns. So what is what they have written? Center of gravity of column loads coincides with the center of footing area, and plan is rectangle. Why? W1, W2 are same. Okay, now coming back to this next diagram, trapezoidal. What is happening here? Columns carry unequal load, so that is why combined footing is provided, but geometry is little bit changed. It is not a rectangle. Don't see all the distance. It is the front elevation. This is the plan of the footing plus column. Here what is happening? W1 is less than W2. You understand this one first. Load on column 1 is less than W2. So it requires larger area. So that is why here you want to have a larger area. Here you lesser area, here you want to have a lesser area. But you need a combined footing. That is why the final shape is trapezoidal. Over which columns bases have been formed. Is that okay? Trapezoidal shape? Yes. Okay. Now this is a typical cross section. What is happening? CG of this column also coming here only, and here also CG of this total trapezoidal is also coming in this one. It is constructed like that. CG of the column and footing coincides, should be there. Otherwise, it will lead to what type of loading? You remember the previous classes. If the line of CG of column and line of CG of this one, it is same, then we call it as axial loading. If it is changed, then we call it as eccentric loading. Eccentric loading will lead to unequal settlement. Unequal settlement. Is that okay? Yes. Okay. Okay, this is also an isometric view. You can easily see columns and their planned area. Here from the diagram only you can see bigger column, smaller column, big load, small load, bigger cross-sectional area of footing, smaller cross-sectional area of footing in trapezoidal footings. Trapezoidal footings. Is that okay? Yes, very simple, no? You can easily see. Now there is one concept called as strap footing. What do you mean by strap footing? Strap footing, I will just tell in brief way. Combined footing is possible when that two columns are located nearby. That time this area and one common footing can be provided. This we have discussed just now. When distance between these columns or these loads is a little bit less, then we can go for combined. What will happen if this column is far away from this column is far away from this, still you want to go for combined? No, because total area of concrete becomes wasted here. So whatever this total area, if you provide combined footing, then lot of concrete will be wasted and it will become uneconomical. So for that purpose, but still they want to have some connection between them. So that time for this footing, okay, and for this footing they have casted. But here soil is weak. What time they will do? To transfer a little bit of load from this footing to this footing, they are connecting one horizontal member here. We call it as beam. So in civil, generally, I am telling generally, horizontal load members in a building load carrying are called as beams. And in building, vertical members which carries the load are called as columns. Columns, struts, stanchions, they are called by the different names. Okay. So horizontal members which carries the load, they are called as beams. So what is happening here? This beam is connecting this foundation to this foundation. Why? This is a poor load carrying capacity. Soil is poor load carrying capacity. So some of the load should come here and transferred by this beam to this footing. So this connection is called as strap footing. Here the load is transferred from this point to this point only. Here soil is there, but this beam is not going to transfer that load to this soil, underneath soil. It is going to transfer that to here only. Okay. So that is what they have explained here. If the independent footings of the columns are connected by a beam, it is called as strap. So we have just now seen. So independent footings connected by a beam, it is called as a strap. Here only it is written strap. Okay. So when it is used, if the distance between the columns is too large. Okay. Too large. So this is large. Sorry, distance between this column and this column is very large. Okay. And combined footing, then it will become very narrow. So it will not going to be correct one. So that time also we can go for strap footing. Okay. Now in this diagram you can see, just to see this diagram I will explain. This is an example for mat foundation or raft foundation. Here one big large foundation base is created. Here on this, here one column will come, here one column come, here one column come, here one column will come, here column, here may be boundary wall. So for all the above ground structure, for all the structures, you are providing one common footing. Okay, that is called as mat or raft. We'll